Hello and welcome to StatC1000 at Kenyatta College. My name is Ray Lapuz. In this video we will be looking at an example problem where we find a confidence interval for a mean, around a mean, but this time sigma is unknown. So the big theory is that we cannot use, but we usually don't use the z distribution for this, and we have to now dive into the t distribution. So this revolves around the idea of student's t distribution. Student's t distribution. And I think the t is usually lowercase, so let's get that. And student is a pseudonym for this mathematician, statistician guy, Gossett, who worked for Guinness. A little side note. And then we'll throw in the formulas as needed. It says, suppose that we have a committee that is studying whether or not there's waste in time in our judicial system. It is interested in the mean amount of time individuals waste at the courthouse waiting to be called for jury duty. The committee randomly surveyed 81 people who recently served as jurors. Sample mean wait time was 8 hours with a sample standard deviation of 4 hours. So note, distinctively missing is from compared to what we were doing before, there's no information about sigma. So sigma is out of the picture. And because sigma is out of the picture, we will rely on student's t distribution to make our interval, our confidence interval. As we read through again, we'll identify the important piece of information that they want. So suppose the committee is studying whether or not there's waste, and then it is interested in the mean amount of time individuals wait in a courthouse. Committee randomly surveyed 81 people, so that is the n. That's the sample size. Recently for jurors, the sample mean, so that's x bar. Sample mean wait time was 8 hours, so this is going to be 8, with a sample standard deviation of 4 hours, and this is going to be 4. So those are the values that we found, or we were looking for. Now, one other value that is needed because we're using the student t distribution is this n minus 1. So n minus 1, you have 81, minus 1 is 80. And this is actually your df, or degrees of freedom. And that is important when we're dealing with the student t distribution. So we want to make note of that. All right, define our random variables in words. So let's write that out. Our x is going to be the mean wait time, or not the mean wait time, but just the regular wait time. Wait time for jury duty. Probably could be a little bit more precise. The wait time for waiting in the courthouse to be called for jury duty. So that's the big one here, x. And then the capital X bar is going to be the mean wait time for 81 people to be called for jury duty. Okay. So that is what we have. Now it says, what distribution should you use for this problem? Only because we don't have, since sigma is unknown, we're going to use student t distribution. Okay. And then now it says construct the 95% interval of the mean time wasted I said wait time, so you could also put wasted time. Construct the 95% confidence interval for the population mean time wasted. State the confidence interval, sketch the graph, calculate the error bound. All right, so again, we have been using our calculator. You can obtain the calculator from this. Make sure you make a copy because you're not going to be able to edit it. It's only viewable, but it's copyable, so you can certainly copy it and then get your result. This is our calculator coming up. But I have several tabs. We want to look for 8-2, the mean. So calculating the confidence interval for mean sigma unknown. Now, if you had raw data, you can put it here, and the calculator will help you find X bar and N and S. So once you put some numbers in here, it'll automatically populate that. But then it's up to you to make sure you copy that onto the actual calculator. And oops, here is the actual calculator in here. All right, so let's gather the information that we already got. There we go. So we have the sample mean X bar. That turns out to be 8. And the sample standard deviation is 4. Oops, I'm sorry. The next one is N, so that's 81. The sample standard deviation is 4. And then the confidence level that we want, I believe, was 95% confidence, so that's 95. With a 95% confidence, your critical t-value, so notice that this is a t-value, is 1.990. So if that was needed at all, you can make sure you add that. And if they ask for the error bound, which they do in this case, it's going to be 0.884, or yes, 0.884 is good. And then the error bound for the mean is going to be based on the mean plus and minus the error bound. So the X bar was 8, and then we subtract and add, and then so we get these numbers, 7.116 and 8.884. Okay, so we'll write all those pieces of information down. And here we have state the confidence interval. Well, let's write down a few more things before we actually write the confidence interval. Your critical t-value, t sub alpha over 2 is equal to 1.990. They didn't ask for that, but let's just say that's good information to have. The error bound for the mean is given by 0.884, and then our confidence interval, our CI, is going to be 7.116 to 8.884. Okay, now the graph of this, we can do this graph in just one-dimensional, like a one-dimensional line, like an interval like this, that has 8 to be our mean, and then it has 7.116 and 8.884 as our endpoints. But really, it comes from a normal distribution. This is normally distributed, and from those levels, we have 95% confidence in here, and then some tails out there that add up to 5%. Our EBM is going to be here, this distance over here, 0.884, which is the same as this distance over here as well. So that could be our graph. So I think we got everything here, our EBM, our confidence interval, and our graph. Now for our last part of the question, it says, explain in complete sentence what the confidence interval means. So let's get this down here. And then this is our template. And let's fill it in with whatever it is we need to fill it in with. So we are 95% confident. So that's the first thing we need to do, that the true population mean And here we have to include what it is we're talking about. So if we want to remind ourselves, the wait time, the mean wait time for people to be called for jury duty. So the mean wait time for people called for jury duty. And I'm going to go ahead and color that just so you know that that actually came from, that's the change. And then here is 71.116. So 71.116. And let's change the color. And 8.884. 8.884. And then we want to also include the units, and I think since we're talking about wait time, these are minutes. And so that's the other change that we did from our template. And I think that completes everything that we need to find for this problem. All right, so I hope you get comfortable with doing these problems and using the calculator and getting the information from the calculator without having to, punch in a bunch of numbers and formulas and stuff like that. I will expect you to know the formulas because some of those formulas are important. So just make sure you have them in some sort of collection of notes that might be useful for you. Okay, I hope that helps. Good luck.